Great. Well, good afternoon, everybody. It is a pleasure to be back with another webinar. So thank you very much to Xavier and to the Campus Testbed for inviting me back to present again. My name is Andy Owen. I am the International Technical Manager for ICL, and I'm here today to talk a little bit about biostimulants, a topic of which I find very interesting, a topic I think that is very relevant for our industry today. You can see my details up on the screen. You can follow me on Twitter if you wish, LinkedIn account there as well. Find me on there if you want to follow some of the social media activity. Okay, so next page. So a little bit about my background. As I said, I'm the International Technical Manager for ICL. The important bits here, I think, are that I'm a soil scientist. That is where I've been spending my career. And, you know, I have worked extensively both in education and in research and trials work, teaching greenkeepers and groundsmen, and also carrying out trials work for the industry. And as I said, biostimulants have been a part of the research and teaching that I've been doing throughout my career. So to start, I guess there's always been a lot of pressure on greenkeepers to produce great quality putting surfaces, and you know, we need to produce those surfaces all year round. And under ideal conditions, under optimum conditions, well, you know, maybe we can manage that quite easily. But you know, there is always that thought about whether biostimulants can, you know, provide any benefit to that situation. You know, and if the stresses increase on the surface, maybe through heat or drought or salinity, then we are very tempted to look outside of our existing armory of skills and materials we can use to biostimulants to try and give us that little bit extra support and help. Okay, just hold on. So today I'm going to cover a few main topics in this area of biostimulants and ask the question as to whether they are a key part of integrated turf management. I'm going to cover a few broad definitions, look at an overview of biostimulant categories, follow that with a little bit of research, and then pick on three specific biostimulant categories to work on. So talk a little bit about carbohydrates, a little bit about seaweeds, and a little bit about silicates, and then finish off. I'm sure there'll be plenty of time for questions at the end. Just having a few issues progressing these slides, so we'll see if we can improve that as we go on. Okay, let's start with a few definitions. I looked to the European Biostimulants Industry Council, who produced a document on this topic in 2013, and they made the following statement. They basically said plant biostimulants contain substances or microorganisms whose function when applied to plants or the rhizosphere is to stimulate natural processes, to enhance nutrient uptake, to improve nutrient efficiency, to improve tolerance to abiotic stresses, and to improve crop quality. There's a couple of critical things in there. You know, we're talking about applying to both the plant or the rhizosphere, so acting on the plant or acting in the soil, and having a range of functions or a range of results, you know, but essentially based around improving crop or turf quality. It is important to also separate out biostimulants from products which have a pesticidal action. So the statement was also made that biostimulants should have no direct action against pests and therefore do not fall within the regulatory framework of pesticides. Now that's quite a critical piece of information there. We do see in our industry some biostimulants marketed and advertised as having a direct action on a pest group, be it a plant pathogen or an insect pest, and in reality they shouldn't be doing that. Anything that we are describing as having proven action against plant pathogen or something like that should be under the regulatory framework of pesticides and should not sit in the biostimulant category. And then a final statement to pull out of this document would be that, you know, biostimulants have have a different or operate under a different mechanism than traditional fertilizers or plant nutrition. So they might contain some nutrient components, but the biostimulant itself shouldn't be having that nutritional effect on the plant. So it shouldn't be acting as a traditional plant nutrient and having some alternative effect. So that would be our starting point. And if we consider those statements, then we could come up with a number of, say, fairly common biostimulant categories. And, you know, we might put within there the microbial inoculants as part of a biostimulant category. Again, we've got to be careful here because some microbial inoculants are registered as biofungicides and can be used, you know, to have a direct action against some of our plant pathogens. So there's a little bit of close relationship between which microbial inoculants are acting as a biostimulant and which are acting as a sort of having a pesticidal action. Another category could well be the seaweed extracts, and I will talk a little bit about those later. We could also think about amino acids and peptides. Again, we could identify a little bit of confusion here because to be an amino acid, you know, it has to have a nitrogen and a hydrogen group, an NH2 group, and plants can utilize nitrogen from amino acids fairly directly. So there undoubtedly amino acids will have a nutritional effect, but there are individual and groups of amino acids that can also have a biostimulatory effect. And so, you know, we need to think about that and be careful how we define these. Another group could be is the humic acids and fulvic acids, these long chain carbon compounds, essentially break down degradation components of organic matter, separated out by how easily dissolvable or how easily soluble they are. They can have a direct action on the root zone, perhaps a direct action on the plant as well. We then have a category described as inorganics, but non-nutrients. And so for those of us who believe that maybe phosphites are a biostimulant rather than a plant protection chemical, phosphites would sit in this category. I'm going to talk a little bit about silicates, which I also sit in this category of inorganics, non-nutrient components. Sixth category would be the sugars, the carbohydrates. We'll talk a little bit about those, common biostimulants, if you like. And then, you know, on top of those six categories, there are a range of others. Things like chitosanes, like plant hormones, like antitransparents, vitamins, organic acids, osmoregulants. There's a broad range of chemicals there, all of which I've seen described as biostimulants, and it can get quite confusing. They all have slightly different actions. So they're the categories we might consider. In terms of my reference points, well, there are a couple of very good sort of scientific studies which I use as points of reference. I'm sure you can find these online. The Marshner Review, which looks at agricultural uses of plant biostimulants, and then the Science of Plant Biostimulants here. These break down our biostimulants into different categories and provide evidence for their modes of action. And if you can get hold of these, I would recommend that you have a read through if this is a topic you find interesting. There are as well a lot of industry press articles that we see appear in the literature. Some of these have some good insight. Some of them are written with more of a marketing slant than a sort of science and technology slant. So we have to be careful what we take from these. If we consider the main components of these two scientific documents, well, they essentially identify some common themes between the categories of plant biostimulants. And those common themes would be that the biostimulant can act to enhance root growth, would be that the biostimulant could potentially act to improve stress tolerance, that the biostimulant could act to improve nutrient uptake. But what is interesting is they do identify that not every product will do all these, so not every product, and not every product within individual categories will do this. So you do need to take these broad statements of features we see coming from biostimulants, quite generally, and not expect to see these responses from every application or every product that we apply. But basically, these will add up to an improved plant health, which is what we are looking to do. So, in terms of plant health, here we have a very healthy piece of turf. It should be very healthy because the starting point of that is we've got some turf with some good genetics. And that should always be a starting consideration. Are you using the best genetic material that is possible? And this piece of turf here on this slide, comes from, a turf cultivar trial where we are testing and assessing the very latest genetics that are out there to provide new cultivars for the industry. So our starting point should be to try and get the best genetics possible. These grass plants are then, only going to operate to their optimum if the light is satisfactory, so they're under good light levels, and then if they have good access to carbon dioxide for photosynthesis and for oxygen, for respiration. And so, we need to be operating in the sort of environment that provides us with a healthy plant. And that would include optimum operating temperatures. That would include growing in a healthy root zone for support, for providing water and air to the roots. And that water and air needs to be provided in, the optimum amounts for plant growth. And then on top of all that, we need to apply the right nutrients. Nutrients will be divided into the macronutrients the plant needs most of, our N, P, K, calcium, magnesium, and then our micronutrients, which are still essential, but which the plant needs much less of. So we've got all these factors to consider even before we think about our biostimulants. And that is probably one of my first take-home messages there, is that we should be providing with the plant, or providing to the plant, optimum conditions that we can in our situation that should consider all these different factors before we then think about our biostimulants. And I use a slide to demonstrate this, which essentially says, don't get sidetracked. This slide essentially shows our macronutrients, and the size at which they appear on the slide is, how important they are to the plant. And you can see that nitrogen far outweighs, the other macronutrients in terms of the plant makeup, followed by potassium, followed by calcium, phosphorus, magnesium, and sulfur. And this little smudge down here in the bottom right-hand corner that you can't see, that is our trace elements. That is chlorine, iron, manganese, boron, copper, molybdenum, and zinc. And their relative size is, their component of a turf plant. So you can see their relative importance to nitrogen. And so, we need to get our nutrition right, I think, And however, we still need to understand the category biostimulants and think about how we might use them. So, to give a couple of examples, if we're approached with the question, can biostimulants help me manage a very disease-prone sward? Here we have Gulf green surface that has had a severe outbreak of Microdopium nivale, so the cool season disease, causes terrible scarring on the turf surface. And you could ask that question, can biostimulants help in this situation? Well, my first response would always be, if you want to treat the disease, you need to use a registered product. But if you want to prevent future outbreaks of this type of disease, well, we need to look at the basic causes. And if we pull a core from this type of turf surface, in fact, I did pull a core from this type of turf surface, and this was what we're seeing under the ground. And straight away you can see that we have a large problem on this screen. We have a huge layer of organic matter buildup overlaying the clean sand, and then we have this anaerobic wet area at the bottom where we've got such reducing conditions that we're producing a lot of a black layer. And in this situation, the question, will a biostimulant provide me with some improvements, is, should get the reply, no, not really. Biostimulant's not going to help here. Have you had a close look at your insect? And the question could come back, yes, but there are biostimulants which we can use to help degrade thatch. There are biostimulants that are suggested can help break down black layer and reduce that, and they're available. And the reply has to be, in this situation, okay, it's fine that they're available, but in this sort of situation, if you're not sorting out your drainage as your primary concern, you're not then working on your maintenance plan to reduce your thatch level, through increased top dressing, through increased aggressive organic matter removal, the application of a few biostimulants is not going to help. We could take another situation, perhaps the opposite to this. I'm operating in an environment where my turf is suffering from heat stress or drought stress. The question may arise, can biostimulants help in this situation? So it's a good question. Yeah, biostimulants have been shown to assist in this abiotic stress management. You know, undoubtedly, yes, biostimulants can help turfgrass manage with drought and other forms of abiotic stress. Some very good evidence to show that. But I would still give you the answer first. You know, hey, have you carried out an irrigation audit and had your water quality checked? And is that something that you do regularly? If you talk to an irrigation specialist, an irrigation technician, you know, they would say that very often, you know, 30 to 50% of every irrigation audit they do identifies problems in terms of, you know, irrigation coverage and the amount of water getting to the surface, you know, and these are real issues that can be corrected to provide improved turf surface, you know, again, before we reach for that bottle of biostimulant to provide us with some sort of benefit. So, in my eyes, the biostimulant is part of an integrated program, you know, when we're not talking about the effects of individual products providing us with that, that unique benefit. You know, this map of turf health surrounded by this sort of integrated turf management plan where everything, you know, plays its part into providing our, you know, improving turf surface. And nutrition is undoubtedly there, but also, you know, how you manage your moisture and how you manage your organic matter, how you manage the light and the air movement and your disease problems and, you know, your plant growth regulation. Everything else plays an important part. Okay, so we go back to our categories of biostimulants. You know, I said we had our microbial inoculants, our seaweed extracts, our amino acids, you know, our humic acids, our inorganics. We had our carbohydrates and sugars, and we have this broad category of other compounds in there. And so I'm going to focus on just three of those. I'm going to talk a little bit about carbohydrates. I'm going to talk a little bit about seaweed extracts and a little bit about our sort of inorganics, our non-nutrients. There is lots I could say about amino acids. There is lots I could say about microbial inoculants. A little bit less I could say about humic acids and fulvic acids, I think. But let's start simply and pick off a few of these categories. So let's start. So our sugars, our carbohydrates group. Essentially, we're talking about an inorganic compound that contains just carbon, hydrogen, and oxygen. I pulled this table straight off Wikipedia, which explains, you know, as we increase in complexity, you know, our sugars through to our oligosaccharides, through to our polysaccharides, you know, we increase the complexity of the compounds that are involved. You know, but essentially these are all carbohydrates. They could all be applied to the turf to get some reaction. We commonly in turf see carbohydrates applied, you know, based on molasses compounds, sometimes described as vinasse, which is a byproduct of the sugar processing industry. And these can all be used as biostimulants. You know, it is an interesting question, though. If we're applying these to turf and we see a response, is that response coming because we're stimulating the microbiology? Or is that response coming because we are stimulating the plant? And this was a question that I sought to answer some time ago, you know, in my previous job when I was working at a college lecturer and a researcher. You know, I did with, I should say, a student of mine did a really nice piece of research, essentially growing grass in a completely sterile environment. So we have some turf grass here growing inside this sealed tube, and this sealed tube is completely sterile. So there is no bacteria, no fungi in there. So we have a plant growing in isolation from any microbiology. What we can then do is dose this agar with some simple sugars. We can see whether those simple sugars have an effect on the plant. Can the plant utilize those sugars directly, or does there need to be this interim effect of the microbiology breaking them down? I think a really fascinating question. What we saw from this trial work, here we have shoot dry weight increasing. We have our control, our increase in sugar content. We could see that as we increased our sugar content, we got an increase in shoot dry weight. The plant was able to utilize those sugars directly. The same could be said of the roots. Same graph here, we change our shoot dry weight for root dry weight. And we can see that as we increase our sugar content of that agar, then we increase our rooting. It's a bit of an artificial environment, but you can see in these exposed plants grown in that situation that where we have increased sugar, we have a healthier, larger, more vital plant in both shoot and roots. So application of carbohydrates can make a difference to plant response. However, when you take this research work out to the field trial situation, it becomes a little more complicated. There are more factors in play. And we did another trial with another really good student of mine out on a links golf course site. And we added in some wetting agents and a microbial activator. Essentially, the microbial activator was a carbohydrate product with a small bit of seaweed and some trace elements in. Carried out a nice, robust field trial, fully replicated, fully randomized. We've got fescue turf, no other cultural practices impacting here, so no fertilizers or whatever impacting. And we can look at the data here. Now, these graphs, when they went through translation, didn't come out in quite the same format, so I need to explain them a little bit. But here we're talking about turf color response, we're talking about our control, and we can see the trend in terms of turf color in that we're getting an improving trend when we add a wetting agent. You know, the wetting agent is allowing the plant to access more nutrition. We get improving color when we add our microbial activator. The biostimulant is allowing the plant to potentially access more nutrition as the bugs are breaking down, you know, the organic matter that is in the root zone. And when we combine wetting agent and carbohydrates, we get an increased improvement. And there should be some letters signifying levels of significance here. You'll have to take it from me that the wetting and the agent and the biostimulant was significantly greater than the control, and the combined treatment was significantly greater than the others. Now, when we look at turf quality, again, the formatting's out a little bit on this slide, but we see the same sort of trend. You know, in terms of turf quality, our wetting agent and our biostimulant can improve turf quality over the control, and they have a combined effect to improve turf quality together. So our carbohydrates and our wetting agents give us a better turf quality. And that trend continues in terms of our rooting. And so we can improve our rooting by combining these treatments. But with the rooting differences, we encountered more variability. This was only a small student research project, and so the significance tests didn't separate out those differences clearly. I strongly believe that if we had more replication than just the 4 replicates we saw, we would see some significant differences coming in here. So what can we say from that? We can say that you know, our carbohydrate category, our sugars, can have a direct effect on the plant. They can also affect the microbes, and by utilizing carbohydrates in certain situations, we can improve turf performance. Okay, next one. Well, I've always been interested in seaweed-based products. You see a lot of them on the market, and when you really scrutinize them, they have different sources of seaweed at different formulations. And again, they have plant acting components and soil acting components. And this makes research quite tricky. Because seaweed extracts are fairly complex. When you break them down to their constituent parts, they contain a range of compounds, some simple sugars, some oligosaccharides, some amino acids, micronutrients, some more complicated carbohydrates and amino acids that have specific actions on the plants, or acting as osmoprotectants or eliciting some plant defense. And seaweeds will also provide some plant hormone-like action to the plant as well. But that said, it's important to say that not every seaweed will contain all these. It very much depends on the seaweed type and how that seaweed has been extracted. And so the reaction of the turf following the application of a seaweed will be very different. When we ask turf managers, professional course managers, what they want to see in terms of the benefits from a seaweed, they all identify a similar thing. They would expect seaweed application to improve stress tolerance and increase root mass. And so, have we got evidence for that, for this particular biostimulatory category to do that? Well, let's have a look. I've carried out a whole range of seaweed trials, ranging back over the years. This was one of the early ones, a field trial. We have 4 or 5 blocks, randomized, replicated, looking at combinations of seaweed and nitrogen in this field situation. Again, this was great work done by a student of mine. And you know what? This trial identified no significant differences with seaweed extracts whatsoever. We saw clear differences with nitrogen, but our seaweed extracts didn't provide us with any difference in this situation. It's interesting because there is a sort of universal turf research truth, and that says that if you are testing a well-performing surface that is not under stress, then turf responses are difficult to identify. And finding significance in the measurements you make is also very, very difficult. I've carried out a number of turf stress trials, where we have clearly generated turf stress. Here's a trial at a research site we use. We have stress here. We're looking at alleviating that stress with a range of biostimulants. Stress was clear and apparent, but the action of the biostimulants to alleviate that stress wasn't. It's always tricky. It's not that those biostimulant categories are not of use. Perhaps their application wasn't optimized, the stress wasn't optimized for the trial results. Perhaps even the measurements we were making weren't elegant enough to pick up the differences. But it is a recurring thing. Here's another trial with stress applied to a turf surface. We see clear treatment differences here, but our treatment differences are just based on our macronutrition, not on any sort of biostimulatory inputs. And as I said a few slides back, our effect of nitrogen, of potassium, magnesium, calcium on macronutrients is much more critical than the effect we see from biostimulants. I see that in a lot of trials that I run. That said, getting back to our seaweeds, there are some benefits if you explore further that you can identify. Here's a lovely little trial that carried out in these clear chambers. These work particularly well in that you can grow individual plants in these chambers. You can dose up these sort of filter compartments with seaweed extract, Run controls, we have a control with the same nitrogen, potassium as our seaweed extract, and we clearly see greater rooting with the seaweed extract. The seaweed extract is able to convince the plant to root harder, root better. And when we look at that rooting in detail, in close-up, we see longer roots, we see more root branching, we see more root hairs than we do in any control. Despite having field trials with seaweeds that sometimes don't show differences, convinced of its benefits in these sorts of trials. We can identify the differences there. Actually, what's nice about these sorts of chambers, just run back a few slides, is as we're running the trial, I can then actually put them on the scanner. I can scan these chambers and I can measure root length, root branching, total root area, if you like, and come up with some pretty robust data, which would tell me that where I apply seaweed product, I get significantly greater rooting. But you know what? I don't see that with every seaweed product that I trial. Here I had another student doing some work on a couple of different seaweed extracts, different experimental setup here. We were growing turf in a golf root zone in these containers with a clear front. And if you grow that turf on an angle, you can train the roots to grow down the clear surface. So you can measure root extension as you go along, which is really useful. And this data showed significant differences, showed that we got an increase in root mass with particular seaweeds that had been extracted using a cold alkali extraction. Where we saw water extractions with added nutrients, did not get that increase in rooting, which is interesting. So this is telling us that we need to be quite careful about the biostimulants that we select for use. We scrutinize trial data and we make sure that the biostimulant you select is going to provide the benefit that you want. This data has been taken out into the field, similar results shown in field trials, mature sward trying to encourage increased rooting, and where we apply seaweed extracts, we can get our increased root mass, which works out to be significant increases in rooting, which is good. As I said, come back to this comment that not all seaweed extracts do this. And of course, here we have an illustration. We've got 3 seaweed extracts. If I extract with different things, with water, say with alcohol-based extraction, or with our hydroxide-based extraction, I'm removing more components from that seaweed. And if I'm removing more components, it could have a different effect on the turf plant. And that is what we see when we run nuclear magnetic resonance. We run those seaweed extracts and identify the components within them. We see that alkaline extraction actually does release more plant beneficial compounds than simple water extraction. And these differences will confer a benefit on our turfgrass plant. Okay. And that's shown up in figures and in a range of experimental work, as I've already identified. Now, seaweed extracts also provide us with some stress tolerance benefits. Again, these figures didn't format through the translation, but essentially what I'm showing here is turf quality on a turf surface, which when we reduce irrigation, we see quality dropping. However, if we have dosed up our golf green prior to that irrigation reduction, we actually see some benefit applied to that turf surface, some quality maintained, and a maintenance of quality which is significant over a number of weeks. So by dosing with seaweed extract, we are maintaining a higher quality turf surface under conditions of serious abiotic stress. So that turf plant is providing us, that seaweed extract is providing us with some benefit in that situation. So some really interesting data coming out there. So interesting that I've become more and more convinced about seaweed extracts. And ICL are funding a 3-year research topic, a PhD in collaboration with Royal Holloway University to look at this link between seaweed extracts and the soil biology and how that impacts on turf performance. So there should be some really good quality data coming out of that PhD to help inform the industry. I think maybe I'll be invited back to present on that data as it develops. Okay, now my final topic here is in this range of inorganic, non-nutrient, and I'm going to consider silicates as that. You apply a silica to a turf plant, we would describe it as a non-essential element. We recognise that plants contain silica as part of their constituents, but by adding silica, we don't see a growth response. Silica is never seen as being deficient in the root zone. But there are bits and pieces of research that are mixed that tell us by adding silica, we can maybe improve turf health. And there was a really interesting piece of research that came out of the US looking at silica to reduce incidence of grey leaf spot. Not acting on the disease, but just reducing the incidence of it. This was really interesting. So as a company, we looked at this in terms of doing some research. We carried out some trials both in Italy and in Spain that essentially asked, can we improve turf health, help manage turf through periods of elevated disease pressure, particularly looking at our leaf diseases, like grey leaf spot, like dollar spot, and can we apply silica to assist or improve turf performance through those periods? I have to note here that we're not acting upon the disease. We're trying to improve turf quality or turf resistance to help that disease better manage through that period. We generated a lot of data in this trial work, but in simple terms, just give me a moment to progress this slide. There we go. In a high pressure year, when we were doing our trial work, we were seeing serious outbreaks of leaf spot on a number of sports pitches where we were running this trial work. But we found that where we had applied silica, in a stadium environment, under conditions where we would expect to see leaf spot outbreaks, we were managing that. But it wasn't just the silica that's part of that. It's part of an integrated program of trying to keep our turf surface as healthy as possible. There's a couple of theories about how that works that basically say that our silica is potentially either creating a barrier to fungal infection in the leaf or improving leaf elasticity, again preventing sort of that fungal outbreak occurring in the leaf, so giving us a little bit of protection. And potentially the same thing could happen in situations where we get high dollar spot pressure. We can use silica as part of an integrated management plan to reduce that pressure of dollar spot. As a company, we provide strategies for management of a number of diseases. You'll find these on our website, essentially looking at a full range of integrated maintenance that you can do to manage your disease. And by adding silica into this sort of maintenance program, potentially improve our preventative strategy for disease management. But it wouldn't have a place in a curative strategy. You know, if you have outbreaks of disease, you have to look at the registered chemicals, the registered fungicides to help you manage that disease in that situation. So it is, you know, what we describe as this ITIF approach, this integrated plan to put a preventative program in place that helps manage stresses, both biotic and abiotic. We see biostimulants as being, you know, a small part of that plan. I sort of describe it as this pursuit of marginal gains. Essentially, it is like an Olympic cycling team, whereby at this level, you know, elite athletes will perform really, really well. So you have to look for absolutely every benefit you can to provide those marginal gains to improve your performance. And biostimulants can be part of that sort of marginal gain increase. You know, looking to just advancing the slide. You know, looking to the common biostimulant categories to support that. Finish off with a couple of slides. You know, we need to be careful. I always say beware of the post hoc fallacy, if I can describe what that is, when we're talking about biostimulants, which essentially goes like this. You get someone telling you, you've got to try this new product, it's amazing. Your response should always be, how do you know it works? Why is it so amazing? And their response might be, well, I tried it and my results are great. And you should reply, well, isn't it possible that your turf was improving anyway? And again, the reply might be, no, I tried it and now my turf is great. And you can see where the post hoc fallacy is coming from. Essentially, just because you put something down on the turf doesn't mean that that is the reason your turf is improving. And we see this quite a bit. You know, what about everything else that is going on? That change in weather, in temperature, the change in maintenance it's carrying out, the change in how that turf is performing from one year to the next, you know, that is also having an effect. And I do hear occasionally people saying, no, I tried this product and now my turf is great. And so this product is causing my great turf. And that's not necessarily the case. You know, there's no problem that we try products, and we need to try new products with our eyes open. Okay, but we need to be careful that we don't interpret responses incorrectly. And you can upset people by raising this situation, you know. And you know, we should be open-minded about our products, but we should try and avoid jumping to conclusions. And we can reduce this post hoc fallacy situation by doing the following things. By making sure that we record the maintenance and the conditions at which our turf is performing, by collecting data, by taking measurements of the turf surface in terms of, say, moisture contents, in terms of turf performance, in terms of disease outbreaks, in terms of playing performance, that sort of thing. We can make a difference by always having a control. Okay, and if we have a control, we have something to compare our surface to. We should replicate things, you know, have repeated studies. And this repetition and replication will, you know, allow us to say things sensible. But the bottom line in all this is that when we're looking at this category of materials to use, we should always be looking for data from independent, robust studies. You know, and if the data is not independent, so it needs to be robust. You know, is it randomized? Is it replicated? And what is the interpretation coming from that data? If we do that, we can't go far wrong. Okay, so finishing up now, you know, how to get the most from our biostimulants, I would have the following comments. I would say, you know, utilize biostimulants, yes, but only to support the right integrated turf management program. We need to make sure that our nutrition is right, our water is right, our maintenance is right. And then biostimulants can add that extra finesse. They can help with establishment, they can help with stress management, they can help with turf health, but we do need to be getting these other things right. Okay, I would say select a product based on trial work, based on supporting data, first and foremost. And remember this thing I'm calling the post hoc fallacy. Just because you applied X doesn't mean that Y happens. Okay, so keep your eyes open when you apply these and think about what else might be going on. So, just switching to the last slide. We have to say there is no silver bullet when we're talking about these. We might see biostimulants as being, having that silver bullet effect, but I actually say no, biostimulants are not that silver bullet effect. And what we really should be focusing on is this integrated turf management program that allows us to improve turf health that we might be able to shoehorn biostimulants into. That's me finished off. Thank you very much for listening. Apologise for a few little technical problems as we were going through there with a few of the figures and with some of the slide progression, but I hope that didn't affect your enjoyment and understanding of what I went through. And if Xavier's on the line, I'd invite him back, and obviously happy to take any questions.
Hi, Andy. Thank you very much. But no, about the technical issues, it was not really a trouble attending the presentation. So
I'm glad to hear. Thank you.
Okay, there are several questions. The first one, let me read it for you. The first one is market biostimulants formulations include nutrients as nitrogen on low rates. Are they necessary to promote the biostimulant effect?
Yeah, that's a good question. A number of biostimulants will be formulated with nutrients. Some of the nutrient comes as part of the formulation. So we would look at something like a molasses or a vinasse as a carbohydrate, but actually that has quite a high content of potassium, a little bit of iron, some calcium, some magnesium as well. So sometimes you get your nutrients as part of the biostimulants. Other times you do see nutrients formulated with a bit of nutrition. We sometimes see that the nutrition helps the biostimulant get registered for sale. So we have to be open in that and saying by adding some nutrition to a biostimulant, it allows it to be more widely used. And so, yeah, my final slides were effectively saying we need to be aware that if we're applying what essentially we're describing as a biostimulant, there could be a nutritional effect as well. The key thing here is that you are clear in terms of the components of the biostimulant that is there, and that you've not got hidden ingredients that are not described on the label or in the supporting information sheet. So not necessarily a problem, there's nutrients associated with the biostimulant. It's more that is completely open and transparent. I have no doubt that a number of biostimulants will work very well without a nutritional component, but sometimes they are essential as part of the formulation. Sometimes they are essential as part of getting a biostimulant registered for use in a particular country.
Perfect. Another one. What do we know about the use of the silica by fungus and bacteria?
Interesting question. I would say we know very little about that. The work so far has been focusing on the effect of silicon on plants. And that support, there is some data out there in that American paper I showed that suggests that these applications of silica, although silica is not deficient in the root zone, we see an increase in silica uptake with the applications, which is providing these potential defense effects. It's an interesting topic. I think one that we will see more investigation of in the future. And you know, I haven't got a full answer there. You know, how silica interacts with the microbial community is very interesting.
Okay. Another one, is the orthosilicic acid form the right form in 2 liters per hectare in 5.5%? Is it a good amount in foliar application per month to prevent some fungus problems?
Okay, I'm just trying to go through that calculation in my head. That seems like a sensible amount. Often with these products, it isn't about the total amount that is going on. It is making sure that your application is in line with the application rates. You know, hopefully a product that is available on the market has been tested to provide these benefits at a set application rate. We often see with biostimulants, you know, by increasing the rate, you don't necessarily double the effect. And so there is a threshold, you reach that threshold effect, and then you don't need to go any higher. So as long as you're applying at a label rate, your product is coming with some clear instructions for use, then those applications would seem right.
Okay, sorry, I like to say that who is doing the questions. The two first ones was from Xavier Millet. This last one was from Bernardo Almeida.
Yeah.
And the next one is from Bernardo Almeida as well. In your opinion, what is the importance of manganese to increase plant defenses? What amount should we have in plant clipping?
A good question. Yeah, I would need to just check on that. And manganese is obviously a micronutrient. It is essential in a trace level for plant functioning. And there is some clear evidence that shows that when manganese is deficient, the turf will struggle in terms of disease outbreaks. So there's a clear relationship between manganese being required and the turf being healthy. And manganese is a unique element. It under some pH conditions, as we move away from neutral, becomes less available, particularly at a higher pH, actually. And so you can see manganese deficiencies. Applying manganese over and above where it is operating, as a deficiency or as an excess, I'm not sure we see any added benefit. So I always see manganese as something that is required up to the level of, where it is no longer deficient, but I'm not sure that excess provides any benefit. I certainly haven't seen a lot of work that suggests that. The second part of the question on the amount that is sensible in the clippings, I'm going to be totally honest here and say I would always go back to a textbook. I haven't quite got that figure in my head. I can provide that information by email in 5 minutes after I go offline, because I know exactly where to look, but I haven't got that data in my head. I'm sorry.
Okay, great. And the last one from Bernardo about trichodermas. What's your opinion, especially in Pythium root attacks?
Yeah, that's a good question, isn't it? There has been some good evidence to suggest that the right strains of trichoderma applied in the right way will work against that sort of situation. And so trichoderma is a registered biofungicide in some applications. So again, I would always be cautious about applying a trichoderma from a company where it isn't registered, because actually it is a registered microbial organism. There is a biofungicide that is based on trichoderma, and that product I don't particularly want to name it, but that product applied at the rates they suggest in the program they suggest provides good control against these sorts of diseases. So yeah, the right product, the right trichoderma applied at the right time will definitely work.
Okay, great. Whenever you have, Andy, because you told me before that you had to stop at whenever you need to. No,
I've got time. No, we can carry on if there's more questions. I thought I would get through my presentation far quicker than I did, so so I was just suggesting we might be finished a little bit early. But no, I have more time if there's more questions.
Okay. Yes, there are some. This one from Federico Climent. Why Vital Nova is a better biostimulant than others?
Well, I don't want to be overly commercial here, and so I just need to be careful what I say. I would say that the ICL Vital Nova range, which I've worked on quite heavily, would have supporting trial data for a lot of the effects. So the marketing that we put with it has been proven, if you like, through independent trial work. And it depends on the product, really. You know, the Vital Nova C-Max, so the Seaweed version, you know, it comes from, in my opinion, the strongest source of seaweed that we can possibly source. So you know, we provide products that have been tested, I think, first and foremost, and that we can put into a program to provide a benefit. But I don't want to turn this into too much of a sales pitch, Savvy, so I better not say too much more.
Okay. Yes, thank you. About the question from Bernardo about the manganese, he says that more than 60 ppms in the clipping.
He's trying to push me for an answer. I think that sounds high to my view, 60 ppm.
Okay.
So if you had 60 ppm in the clippings, I believe that would be fine. Like I say, I'm actually looking at the book. It is over there that I could look in. That would give me that exact answer, but maybe I'll reply straight afterwards.
Okay, another question from Scott Little. Any idea of applying any of these biostimulants reducing the threat of fairy rings on greens, knowing that you will have restrictions on using fungicides all over Europe and in particular Portugal and Spain?
Yeah, I'm nodding my head. That's an interesting one, isn't it? Okay, fairy rings are a difficult organism to deal with because they're situated in hydrophobic sand, so difficult for any liquid to get down to it. You know, I should start by saying, you know, we have seen successful control of fairy rings using, an azoxystrobin with a penetrant wetting agent applied at the right time. You know, I'm happy to say that, you know, there is some good effect from that. If we remove the active from that, then, you know, we are struggling a little bit in our control. I have seen some preliminary work which would suggest that sort of probiotic applications of particular strains of fungi can work against a fairy ring fungus. But of course, if we're putting that on the label, these would need to be registered products. I have not seen in-field data of that. I've seen sort of, we call it in vitro, so Petri dish sort of style studies where we can inhibit the fairy ring fungus using a couple of other unique fungi. It is an area of interest. I don't think there's a commercial product out at the moment, registered or unregistered, that I've seen great success with, but it's an area I think we need to look at and move into, you know, for when these actives come off the market. I would almost say in the next 3 or 4 years we'll see something come to market where we will be seeing this sort of control from a biological, but it will need to be registered in that case.
Okay, and the last one, Andy, Bernardo is asking, in biological terms, which are the enemies or antagonic microorganisms of Pythium root?
Again, that's a good question. I think that is I would be looking to our microbiological expert to provide that. Obviously, the trichoderma is working in terms of occupying that root space, a bit like a probiotic, so filling that root space up so that the Pythium can't occupy the same space. So it's having an antagonistic effect by outcrowding it. And I think there are a number of different fungi that actually achieve that end. Like I say, the trichoderma has been proven to be able to do that, and so is a registered product. More information is probably requires a plant pathology expert rather than me to provide that answer.
Okay. I said before that that was the last one. Do you have time for another one?
Yeah, of course. Yeah.
Yes. Okay. That will be the last one. Sorry for everybody.
No problem.
If not, Andy's going to kill me. Okay. From Pedro Carvalho, I guess is from Portugal. For fairy rings application, azoxystrobin plus H2 Pro or H2 Pro, what maximize?
Yeah. I mean, the key with having effective fairy ring control is to be able to get the active ingredient down to the fairy ring fungi in the root zone. And if you're moving through a hydrophobic soil, it needs to be adjoined with a good penetrant wetting agent. Obviously, we sell our own penetrant wetting agents, and that will do the job. There are a number of them on the market. I think there's some fairly strong data coming out of Mike Fidanza's group in the States, which demonstrates this nicely. The combination of azoxystrobin with a penetrant wetting agent working very nicely. So there is some more information online if you do a search, or you search on Mike Fidanza, who is like the fairy ring expert in the world. I think he would be able to you'd be able to find that information out really clearly.
Great. So really that was really the last one. So
Good.
Thank you again for your presentation, for your time answering these several questions. So
you're welcome.
Thank you very much.
I enjoyed it. I hope everybody found it useful, and obviously we'll be happy to do future webinars if I get invited.
Yes, of course you are welcome in the near future.
Good.
Okay. So let me say goodbye to the attendees in Spanish.
Yeah.
Okay. Bueno, pues nada, pues hasta aquí. Agradecemos la colaboración de Ande, que bueno, ha estado abierto a responder todas vuestras preguntas, y como bien sabéis, todas las preguntas que vais haciendo pues enriquecen la presentación y aportan más interés al proyecto.